Now, let's move on to multidimensional arrays. The array class also has a method to create multidimensional arrays of any class type dynamically. This is done with this version of the newInstance method. The first argument to this static method is a class object representing the array component type. The second argument is a variable argument list for the number of dimensions. The return value is an object type for the generic array. Now, if you call newInstance with a zero-dimensional array for the variable argument list, or with void.class as the class type, the method throws an illegal argument exception. This method also throws a negative array size exception if you call it with negative dimensions. Now, to see how this works, let's look at an example. Suppose a getMyClass method returns a class object for an array component type. This call to array.newInstance creates a two-dimensional array of the specified type. The array has 3 rows and 5 columns. This is the Array2D create program, which shows you how to generate generic two-dimensional arrays from string class names at runtime. This program is very similar to the one-dimensional example that we showed you earlier in this lesson. The main program creates a string array of class types for the integer, float, and double types, all living in the java.lang package. These class names represent array component types that are all unknown at compile time. Now, inside the for loop, we'll call the create2D array method with the component type from our string array and the rows and columns representing the array dimensions. When this method returns, we have a two-dimensional array of number types. Let's compile and run this program now and see what we get. The output window shows 3 two-dimensional arrays, all 2 rows by 3 columns. The first time through the for loop, we create a two-dimensional array of integers. The second time, a two-dimensional array of floats. And the third time, a two-dimensional array of doubles. Now, for each array that's created, we'll use our array object to call getClass followed by getSimpleName. This displays the array component type and the 2 sets of square brackets that you see here. Now, the array.getLength and the arrayGet and set methods work for two-dimensional arrays, but they're a little bit tricky, so let's talk about that. To get the number of rows for the two-dimensional array is straightforward. Just call array.getLength with the name of your array. But to get the number of columns for the array, we need to make sure we are accessing a row in the array. Here it doesn't matter which row, since the number of columns is the same for each row. So we'll pick the first row with a 0 right here. Now, the call to array.get returns a one-dimensional array representing the first row in our array. And if you pass that to array.getLength, you'll get the number of columns in that row. Let's scroll down now and see how the create2D array method works. This method has 3 arguments: a string class name for the array component type, and integers for the number of rows and columns. The return value from this static method is a generic two-dimensional array type. Now, inside this method, the first thing that we'll do is call class.forName with the class name string to get a class object. We then call array.newInstance with this class object and the rows and columns. And since newInstance returns an object type, we must cast the return type to a generic two-dimensional array. And the suppress warnings annotation allows this generic cast, so you don't have to cast in user code when you call this method. Okay, let's bring up another Java program now that shows you how to access array elements from these dynamic two-dimensional array objects. This is Array2D Elements, which is similar to the Array Elements program shown earlier in this lesson for one-dimensional arrays. This program shows you how to access elements in dynamic two-dimensional arrays. Like before, there are 2 static methods that we'll look at here: make2darray and print2darray. Make2darray creates a two-dimensional array of any type and initializes all the array elements to a specific value. the print2d array method displays the elements from this two-dimensional array object. Let's look at make2d array first. This method has 4 arguments: the number of rows, the number of columns, the class component type, and the initial value. Now inside make2d array, the first thing we have to do is create an array. And it's not possible to do this with new because the type is unknown. So we call array.newInstance with the class component type, here int.class, the number of rows, which is 2, and the number of columns, which is 3. And after newInstance returns, we now have an object reference to this newly created two-dimensional array. Now it's not possible to access array elements with square bracket notations here, so we must use the array, get, and set methods. And we'll do this with 2 for loops, one for the number of rows and the other for the number of columns. To set each element of the array to an initial value, we have to make sure that we're accessing the correct row first. So this call to array.get gives you a one-dimensional array representing a specific row in our two-dimensional array. We then use that as the first argument to array.set to modify the element in that row. Note that these set and get methods in the array class are completely generic here, which is what you want. And after the for loop, the method returns the initialized array to the caller. Let's compile and run this program now and see what we get. In the output window below, you can see that we have created a 2x3 array of integers with all of the elements initialized to 1. These lines were generated by the print2d array method. Now before we show you this method, let's run the program again with different array types and dimensions. Here's an example of a 2x3 array of doubles, initialized to this value. And here's an example of a 2x3 array of strings, initialized to this value. And here's an example of a 5x8 array of strings, initialized to the same string value. Note that the make2d array method can create and initialize two-dimensional arrays of any type. And like before, if the initial value is the wrong type, like this, the program throws an illegal argument exception. Let's put things back to the way they were when we started, like this, and scroll down to look at print2d array. The first thing we do in this method is call array.getLength with our array object. This gives you the number of rows in the two-dimensional array. Now to get the number of columns requires the technique we showed you in the previous example program. We need a row in the two-dimensional array, so we'll use index 0 to pick the first row. And when we call array.getLength with the one-dimensional array returned by array.get, we get the number of columns in that row. Next, we call getClass followed by getComponentType. This gets a class object for our array components. Now we can loop through the array and print each element. And we'll do that with 2 for loops, one for the number of rows and the other for the number of columns. And for each row in the first for loop, we'll call array.get to access the current row. We can then use that row array in the second for loop to access array elements. Like before, we want to print array elements in a nice format that is type independent. So we'll compare our class component type against a few specific array types here, and that would be int square bracket dot class, double square bracket dot class, and string double bracket dot class. For each of these array types, we'll call the appropriate get methods to read the array element in the specified row before printing its value. So for int square bracket dot class, we'll call array.getInt with a row array, which returns an integer. For double square bracket dot class, we'll call getDouble with a row array, which returns a double. And for string square bracket dot class, we'll have to call array.get with a row array, since string is a class type. Because this method returns an object type, we must cast its return value to a string before printing it. Okay, that's it. You should be able to apply the techniques we've shown you here to 3 dimensions and higher for dynamic arrays if you want.